This experiment is known as exploratory data analysis, and this is my first experiment. And remove color column. I remove the irrelevant color column from the data frame. I use the drop function that in case is equal to true to make the change permanent. This helps clean unnecessary data. Then I display the top 5 rows. Then the second number, I remove the duplicate rows. I remove any duplicate rows using drop duplicates. The in case and the in case is equal to true arguments update and the data frame directly. After cleaning, I display the shake to confirm the outcome. This ensures data accuracy. And the third one, I rename the column class to category. I rename the class column to category. For better clarity, I use rename function with in place equal to true to apply it directly. Then it displays the top 5 rows. This improves column readability. Then then the next one, I drop the rows with missing values. I use drop any function to remove the rows with missing data and store the result in a new data frame without modifying the first name. Then I print out the shape of the clean data. This is useful for handling null values safely. Then for the fifth one, I created the central tendency of score. I calculated the mean, median, and mode of the score column. These values were tell us the center of data distribution. I used built-in pandas functions like mean, median, mode function. It gives a basic summary of column. For the sixth one, variability measure for score, I calculated variance, standard deviation, and range of score. These show how spread out the data is. The main functions gives the range. This helps understand score variability. Then for the seventh one, I calculated the IQR for score. I calculated the interquartile range using Q3 minus Q1. This helps how spread out the middle 50% of the data is. I use the quantile function for Q1 and Q3. Then I printed the IQR function. For the eighth one, I calculated the Z score for score using stats dot z the score function. This shows how far each value is from the mean in terms of standard deviations. I converted the result into panda fields. For better viewing, it is helpful for detecting outliers. For the ninth function, I created a heat map using Seaborn to visualize future correlations. I selected 4 unique columns from the data frame. The heat map shows which future or strong related. Then I saved the plot as an image. For the tenth one, I created a new data frame with 2 additional rows of data. Then I used p.concat function to append it to the existing one. After that, I displayed the last 5 rows to confirm the addition. This shows how to insert rows dynamically. For the 11th function, I created I filled missing values in the petal width. I column missing is me. I use fill NA function with in place is equal to true for direct replication. This method keeps the data balanced. Finally, I printed the last 5. For the 12th one, I created a box plot for score column using Seaborn. It clearly shows any outliers outside the discourse. I save the plot image as well. This gives visual checks for anomalies. For the 13th one, I remove the outliers using IQR. I made a copy of the original data frame and applied IQR method to filter out scores outside 1.5 times the IQR range. Then I plotted the clean data using boxplot to visually confirm outlier removal. For the 14th one, I calculated the Z score. I removed the scores with values above 3 or below -3. Then I recalculated the score on the clean dataset. I used another boxplot to compare results. This is another common outlier removal method. Then for the 14th one, I used df.pay to index to get the index of the last 2 when I drop them using drop function, this removes the rows I had added earlier. Finally, I confirm by displaying the last